find the stationary points on y is equal to minus 5x to 6 minus 12x to the 5 and determine their nature. By determining their nature, meaning finding whether they're maximum, minimum, or point of inflection. And what we're going to use for this is we're going to use this as an example to how to use the second derivative test. So first of all is find the first and the second derivatives. So if we've got y is equal to minus 5x to 6 minus 12x to the 5, then if we differentiate, we bring the 6 down, we're going to get minus 30x to the 5 times 12, which is minus 60x to the 4. Taking the second derivative, we have to differentiate this again, so we've got 5 times minus 30, which is minus 150x to the 4th, and 4 times minus 60, which is minus 240x cubed. Now it's a good idea to take out any common factors here. So here if we take out minus 30x to the 4th, we're going to get left with x plus 2. Notice it's plus 2. And then for the second derivative we're going to take out minus 30x cubed, which is going to leave 5x plus 8. If you think back, if we multiply back the minus sign in there, we're going to go back to a minus. Put dy by dx equal to 0, so we need to take this one. Now the thing you need to be careful is taking the right thing each time, because you've got three things: y, dy by dx, and the second derivative. So we're going to take this one and put it equal to 0. So it's minus x to the 4th, brackets x plus 2 is equal to 0. So either x is equal to 0 or x plus 2 is equal to 0, which means that x is equal to minus 2. Or x is equal to 0. And then we test using the second derivative test. So at this stage, write down the second derivative. So it's minus 30x cubed 5x plus 8. So when x is equal to minus 2, and what we do is we put minus 2 in here. We're only interested in the sign. So if we cube a minus sign, we get a negative. So we've got a negative times a negative. So minus 30 times minus 2 cubed is going to be positive. And 5 times minus 2 plus 8 is a negative. So positive times a negative will give me a negative. Therefore, x is equal to minus 2 is automatically a maximum point. When we put x is equal to 0 in here, when we put it into the second derivative, we're going to get 30 times 0 cubed, which means that the second derivative is going to be 0. Now we're stuck, because it could be a point of inflection, it could be a minimum point, or it could be a maximum point. So we have to go back and use the first derivative test. And this is why it's taught as well. So we have to make this table. We'll look where x is just less than 0, and look where x is just bigger than 0. And now we have to make sure we use the first derivative. Dy by dx is equal to minus 30x to the 4th, x plus 2. So we're going to take minus a half. We're only interested in the sign. So we put minus a half in here. If you raise anything to the power 4, it's positive, but you still got the minus sign in front. So we've got minus. And minus a half plus 2 in there is going to be positive. A minus times a positive is going to give me a negative. At a particular point, it is dy by dx is 0. And then just after, we'll take a half. So putting a half in here, same thing. This will be negative. And this will be positive, so negative times a positive again gives a negative. So this goes negative, 0, negative. So we can see that this is a point of inflection. Okay, and the final point is to find the y coordinate. So when make sure we use the right one. We're using y this time. So substituting in when x is equal to minus 2. Y will be equal to 5 times minus 2 to the power of 6 minus 12 times minus 2 to the 5. Minus 2 to the 6 is plus 64, and minus 2 to the 5 is minus 32. And then when we simplify that, minus 5 times 64 minus 12 times minus 32, we get 64. When x is equal to 0, we can see that y is also going to be equal to 0 very clearly. So the last bit, conclusion. At minus 2, 64, we have a maximum point, and at 0, 0, we have a point of inflection. Okay, let's just have a look to finish off with the sketch. You weren't required to do the sketch, but here is a copy of the sketch. And if we look at the sketch here, here we can see the maximum point, and here we can see the point of inflection. If I was to attach a point here to the curve and then select, go back to select mode again and select object and put tangent, I'm going to change the colour of that. Let's make it red. Okay, and if I move that there, we can see very clearly that we have a horizontal tangent here. Okay, let's move that out of the way a minute, and then because it picked up the yellow thing, and then here also we can see we have a point of inflection. We can see that the curve goes from one side to the other, which is a point of inflection. If we select this one here by first selecting the curve and then selecting this one, let's get rid of the gradient one there, okay, and let's label that. This will give me the first, sorry, we've got points still selected, so just select that and then select the text. That will give me the first gradient of the whole curve. And just to show you what we got here, the gradient is equal to 0, but the gradient of the gradient at this particular point is negative, okay, and also at the point of inflection, the gradient function is also equal to 0. Yes, in this case it was a point of inflection, but it's not always the case. Okay, so this illustrates the use of the second derivative and sometimes where it will not work.